Hi students, now in this video we are going to discuss about the turbines and the classifications of the turbines. So first of all, what do you mean by a turbine? Like we see what is mean by a turbine, what do you mean by pumps. Okay, in this topic we are going to cover up the turbines and the pumps. Normally turbines are used for the production of electricity when in the higher power plant. Okay, so electrical power plant, thermal power plant, or where we are going to use these turbines, there steam is going to be produced in the boiler and the steam is generated, what it is generated in the boiler, it fed over to the turbines. So there turbines, the energy is going to be created by the getting the conversion of fluid into mechanical energy, right? So whether it may be a steam or it may be a hydraulic energy, whatever, a steam turbine we call it as, and hydraulic turbines we will call. So it depends upon the turbines, mainly the turbines which is used for the conversion of the hydraulic energy into mechanical energy. So in power plants, so hydroelectric power plants, we are going to use the hydro powers. So there it will be used. In the previous classes also we have seen that how in the first module we have seen wind energy, hydraulic energy, all the things. So the turbines are used for the conversion of the potential energy and kinetic energy of the water, and it is used to the rotate the shaft of the turbine, right? So here water turbines are mostly used. Where we are using the water turbines, it is used in the hydropower station, with where the dams which having more water. Okay, reservoir dams are the reservoir where water is getting stored, and the potential energy of the water, we are going to use that energy of the water, and through the pipe we are sending the water through the pipe, and we are hitting the turbine blades, and that energy is converted into a rotary motion of these blades, which will create the generator to produce the electricity. All right, so here how the turbines are classified and what is that theory of operation or the principle of operation we are going to see here. The flowing water which is directed from the dams through the pipes, so we are directing the water, and we mix the water to hit on the blades of the turbine runner. So it creates the rotation by getting the water, getting the force from the water. So the runner is spinning and the force act through the distance. So the energy is transferred from the water flow to the rotation of the turbine. Okay, this is how the turbine blades are going to be rotated. We can see the turbine blade here. It's a shaft, we call it as Pelton turbine. In detail we will see about in the next videos how the turbine blades are there and what is a Pelton wheel turbine also. So this turbine here, what it is there, the water is going to be hit on the turbine blades. So the turbine blades are going to be rotated because of the potential energy which is the water has in the dams, that will make it into a rotation. Now the classification of turbines, let me see how many classifications are there. One is first based upon the energy at the inlet of the turbine, because the turbine blades are going to be rotated with the help of the water flows. So on how the water is getting flowed, and according to that the energy we are going to divide into impulse turbine and reaction turbine. So how the water is going to be hit on the turbine blade. So impulse turbine is the energy where in the form of kinetic form, where the water is getting hit on the turbine directly. We call it as Pelton wheel turbine. There are examples for these impulses, Pelton wheel turbine and the turbo wheels. The reaction turbine, where the both the kinetic energy and pressure energy in the form, it will hit on the turbine blades. So here it's Francis turbine is an example. In the further classes, further video, we are going to discuss about the Pelton wheel turbine and Francis turbine. So the classification of hydraulic turbines based on the direction of flow of water through the runner. So how the water is going to hit on the blades, whether the water is hitting on the blade in a tangential manner or radially inward or radially outward, axial flow. Okay, so the axis, the movement of the water which hits on the turbine blades is very important. How it is hitting, the direction of hitting in the blade is very important. So here the tangential flow turbines are there, where the direction of water is tangentially to the path of rotation. In the shape we are going to discuss about the Pelton wheel turbine, which is the example for it, and another case is the radially outward direction. So water enters and it will move radially, rotate the turbine. And next one is axial flow turbine, where the water flows parallel to the axis. When the water flows to the axis of the turbine, we call it as axial flow. Kalpan turbine is one of the example for it. And mixed flow, that is modern Francis turbine, which helps, which has the water enters radially in the outer periphery and leaves axially. So this is what the mixed flow turbine. One by one we will see the working principle. And the third classification of the turbine is based on the pressure head. We call it as head in the sense pressure head. So it depends upon the how much pressure is there in the water level. There are three different types of pressure heads. We can classify these turbines as high head turbine, medium head turbine, and low head turbine. The high head turbine is one where this heavy pressure turbine, that is a Pelton wheel turbine, and it is one of the impulse turbine also. And medium head is, it can withstand some bar pressure. For the medium level of pressure, there we are going to discuss about the Francis turbine as an example for it. And low head level, low pressure head level is a Kalpan turbine or Propeller turbine, which will be used in the marine ships. So next one is the speed. According to the speed of a turbine, it will be divided as a low specific speed, high speed, and a medium speed turbine. The low speed turbine, the Pelton wheel turbine, is a low speed turbine when comparing to the Francis turbine, which is a medium speed. And high speed is in the case of reaction turbines, Propeller or Kalpan turbine, we call it as high speed turbines. And based on the name of the originator who invented the turbines design, so we call it as Pelton wheel, and impulse turbine is one of that. And reaction turbine, we call it as Francis turbine, Thomson turbine. They are the authors, they are the originators, they are those who are invented the types of turbines. On the names also it will be there. So the turbines are basically classified mainly based on the pressure, medium, low level, medium, and high level, and the axial flow or tangential flow, that's where the water gets hit on the turbine, on what way. So these are the basic classification of the turbine. So based on the head and based on the speed it is classified, and based on the flow of turbine, flow of steam or flow of water, according to the where the direction of flow of water. So this is the basic classification of the hydraulic turbines. So in the next video we will see one by one what is a Pelton wheel turbine and what is the principle of this. These are all the things we will see in the next videos.